everyone, welcome to our last lecture on Introduction to Metrology. Myself, Mr. Bipin Patil, lecturer, Department of Mechanical Engineering at Sharat Institute of Technology, Polytechnic, Yadra. So, let us start with our today's content. So, taking overview what we have learned in last lecture. So, let us see the last lecture contents. We have studied the characteristics of measuring instrument, errors in measurement, sources of errors, types of error in measurement, and we have seen the important question on the same. So let us see what we are going to learn in today's lecture. Factor affecting on accuracy, factors for selection of instrument, precautions for using an instrument, least count of measuring instrument, and important question on same content. So let us start with our today's content. In previous lecture we have studied two major types of errors, systematic error and random error. So today take a glance on difference between systematic error and random error. So let us start with the difference. So systematic errors are repetitive in nature and are of constant and similar form, where random errors are non-consistent. Second point, systematic errors result from improper conditions or procedures, where random errors are inherent in the measuring system or measuring instrument. Third point, except personal error, all other systematic errors can be controlled in magnitude and sense, where random error, specific causes, magnitude and sense of these errors cannot be determined from the knowledge of measuring system or conditions of measurement. Fourth point, if properly analyzed, these errors can be determined and reduced or even eliminated, where random error cannot be eliminated but the results obtained can be corrected. Finally, these errors include calibration errors, errors due to variation in atmospheric condition, variation in contact pressure, parallax error, or we can say observational error, and misalignment error, etc. Where random error includes error caused due to variation in position of setting standards and workpiece, errors due to displacement of lever joints of instrument, error resulting from backlash, friction, etc. So it is the difference between random error and systematic error. Such kind of question will be asked in university or board exam. Let us see our next content. So starting with the first point, factors affecting on accuracy. Here, calibration standards affect on accuracy of a measuring instrument or measuring system. It may be affected by environmental conditions like thermal expansion, time, properties of material and position of use. Second, workpiece being measured is also affects the accuracy of instrument. It may be influenced by cleanliness of a particular workpiece, surface properties of workpiece, alignment of work center, etc. Third, measuring instrument. It may be affected by inherent parameter like hysteresis. It is one type of a dynamic characteristics, friction, backlash in particular instrument, etc. Fourth, precision or inspector carrying out the measurement. The human operator carrying out measurement by not have the required skill or improper handling, use of incorrect method and less training may lead to error in the system. Such kind of errors called human errors. And last, environmental influence. So already we have studied in environmental error, change in environmental condition like temperature, humidity, lightning, vibration, etc. may largely affect on the accuracy of measuring system. So these are the 5 factors which are largely influence on accuracy or measurement of accuracy. So let us see the next content. So as we studied in first lecture that measurement is influence on control system. So for measurement, instrument is required. So let us see what are the factors for selection of instrument. First, quantity to be measured. For example, length, height, angle. Exactly what you are going to measure, what you want to measure is the first criteria which selects your instrument. Second, measuring range of an instrument. So let us see the third point, precision of instrument. So each and every measuring instrument should be precise to take repeat measurements, sensitivity and reliability of an instrument. So as we have studied in characteristics, sensitivity should be moderate, it should not very high or it should not very low, so it can cause measuring delay. Fifth, ease of operation and accuracy. Exactly, it should need very easy operation and it should give accurate readings. Last, maintenance required. So particular instrument should be very less so that we can use it very durable period. Design and constructional details. And last one, cost of an instrument. So as we seen, one should always keep in mind that all the factors for selecting of an instrument. So let us see the next point, precaution for using an instrument. So following precaution should be taken while using an instrument for getting higher precision and accuracy. First, instrument should be handled carefully. Second, as far as possible, highly finished surface should not be touched by hand. When the equipment is not in use, it should be protected from atmospheric corrosion. Fourth, hands should be washed and petroleum jelly is to be applied before handling instrument. Fifth, highly finished instrument like slip gauge should be handled using piece of leather. Sixth, instrument should be packed properly after use. 7. Place for storing the instrument should be moisture and dust proof. 8. Instrument should be handled as less as possible. Precise instrument should be maintained at temperature of 20 degrees Celsius. And last one, brushing is not recommended for instrument. Previously we seen the factors affecting on instrument, we seen the factors selection for measuring instrument, we seen the precautions while using measuring instrument. So let us see the next concept of least count. What is exactly mean by least count? Or it is mandatory or it is very useful while selecting the instrument? Yes, it is. So let us see the definition of least count. The minimum measurement that can be made by a measuring device is known as least count of that particular instrument. So basically there are three images showing the different application of measurement. First, protractor, second, steel rule, and third one is Vernier Caliper. In first image, clearly seen that there is a 0 to 180 angle clockwise as well as counterclockwise. Here a single line showing 1 degree of engraved scale. So its least count is 1 degree. In second image there are two rules or two scales, figure A, figure B. First figure A showing, in that figure we clearly seen 0 to 1 there are 5 lines engraved on it and one line carries least count of 0.2 centimeter. Below that figure B shows scale of least count having 0.5 centimeter, because 0 to 1 there is only one line which can be measured as a least line, and below that Vernier Caliper shows there are two scales, one is main scale, second vernier scale. On main scale it is clearly seen that there is a least count of a 1 mm, and below that vernier scale having a minimum least count of 0.9 mm. So let us see how exactly the least count is calculated in Vernier Caliper as well as in micrometer screw gauge. So it is very important in the measurement point of view, we must know that the least count of every instrument that we are going to use. So here let us see how exactly the least count is calculated for Vernier caliper. So it is defined as least count is equal to smallest division on main scale upon total number of division on Vernier scale. The figure showing the smallest division on main scale, earlier we have seen the smallest division is 1 mm upon the total number of on Vernier scale. The total number on Vernier scale are 50. So it is seen that the least count of a Vernier caliper is 0.02 mm. So it is mean we can measure up to 0.02 mm on Vernier scale. Similarly, micrometer screw gauge least count calculated as per the Vernier calipers. So let us see smallest measurement on main scale upon total number of divisions on circular scale. In Vernier caliper there are two scales, main scale and Vernier scale, but here in micrometer screw gauge one scale is horizontal placed, that is called main scale, and one is vertically placed which is engraved on thimble, that is called circular scale. The image showing here horizontal scale having 0 to 1, and in between there is a one line which is exactly placed at a center, that is 0.5 mm, so that it is least count of that particular horizontal or main scale. Here on thimble, on circular scale, there are 50 number of divisions which are equally engraved. So least count of micrometer screw gauge is equal to 0.5 upon total number of division 50 is equal to 0.01 mm. So it is make comment that where the least tolerance required or very close tolerance required, using micrometer is more effective than Vernier caliper. So it is all about the today's content and the end of this chapter. So let us see what kind of questions will be asked in university point of view or board point of view. So first question, difference between systematic error and random error, which we have seen in this lecture. Second, explain the factors affecting on accuracy of measurement. What are the factors affecting on the selection of instrument? Fourth, explain what is least count. Such kind of question is also asked in interview or your interview point of view. This is very important question. So you must know the least count of each and every measuring instrument that can be used in laboratories. And last one, least count of Vernier caliper and micrometer screw gauge. So this is all about today's lecture. If any queries or doubts, ask in comment below. Thank you. Thank you very much.